and I'll get started here.
Okay.
So I've grabbed question 2 from the differential equations. These turn into indefinite integrals in some sense. I mean, they're actually all the same. It's just they're just presented differently. The goal here is to get the y's on the left and the x's on the right. And you can only use multiplication or division. You're never adding or subtracting. So you're going to multiply both sides by the same thing here, y squared plus 1. So you get y prime, which is really dy dx. And you're also moving this to the other side here. So depending on your instructor, like I don't know how much you actually need to show, but like the net result of all this, you know, multiplying both sides by y squared plus 1, moving the dx, is you get the integral y squared plus 1 dy equals x dx integral. Like this is what I want to see if I were grading your test. I want to see that you can get it to that position there.
Okay.
Okay, and these are both indefinite integrals. One's in terms of y, one's in terms of x. 1/3 y cubed plus y equals 1/2 x squared. I have as a preference put only the c on the right hand side. Okay, and since this one does not have an initial condition, since it doesn't have like a, you'll see in question 10, it doesn't say like y of 0 equals 0. Like for me, this is done. Now are your retakes multiple choice, short, free response? What do you know?
Free response. They're like our regular tests, so they have like nothing to do with the AP.
Okay.
But they're just, he's doing like the few questions from each unit, like reviewing little chapters in the unit basically.
Right, so I feel like this is done. You cannot solve for y because there's 2 y's and one's to the power of 1 and one's to the power of 3. It's impossible. Yeah. So this one's completely done. Let's look at well, I'm going to violate something I just said earlier. Math is always about the exception. So number 6 is somewhat of an exception here.
Okay.
I mentioned you only multiply and divide, and that's generally true. Here you actually have to add the xy to both sides. So you have y prime equals xy, and then you separate here by dividing. So keep that in mind. I mean, generally it's multiplying and dividing, but occasionally you get a situation like this.
Yeah.
Let me go back and talk about 4. 4 is somewhat interesting. So there's this k, which is not a variable, it's a constant, and you have a choice whether to move it left or right, or keep it on the right. There is actually no y to move left. You just have to actually move this dx left. Okay. So it's kind of up to you. I would just leave it on the right. It's rare that I would put it on the left, I guess is why I'm bringing that up. So this is k integral 10 minus x dx, and this is not the constant of integration. It's part of your final answer here. Okay, so that c is over here on the right. You got a y equals on the left. Okay. So could you maybe just scan over 1 through 9 and just maybe, I mean, we did 2, 4, and 6. Is there any there that you would like me to review? Because I'm going to move to 10 through 14 next. There's not really much more to say on these.
Yeah. Let me just see. What would I do for 8? Would I divide the x?
Yes, and divide the y.
And divide the y, so bring the x to the other side and bring the y to the other side.
Yes. Okay. 1 is also kind of, I mean, now that I'm looking at it, 1 is kind of awkward if you don't know the first thing to do.
Yeah, could we do 1 and then we can move on?
Yeah.
Oh, wait, actually, could we do 1 and 9?
Of course, yeah.
You always get me. I always overthink.
No, I mean, overthinking is there's a lot of power in that.
I always feel like there's more to do when there's an e in the equation than what I'm doing. So.
Yeah. So this one, like, there's a couple of things I'm noticing, like, well, maybe it's a factoring problem, but maybe it's not. But then I noticed on these two have a y. So if you factor out a y from both of them, you get 1 plus x squared.
Okay.
Like that. And you have a 1 plus x squared here. And it reminds me of factor by grouping, because you can actually factor out 1 plus x squared from both of these, because there's really like a 1 there. So
Yeah.
it becomes 1 plus y times 1 plus x squared. And the reason I'm doing all that is you really need to get y on the other side. But I mentioned, you can't just add and subtract. Like you could subtract y, but you need the y to be adjacent to the dy. So that's why you can't just add and subtract it.
Okay.
So now though, you can divide by 1 plus y on both sides.
Okay.
And you can move the dx over. Now there's an unlimited pool of questions to like manipulate to get down to like this, meaning this just happens to be factor by grouping. You could get regular factoring, like really anything is in play from algebra 1 and 2, which, and that's not great, but it's they could do that. So this equals integral 1 plus x squared dx. So notice you separate them, and then we'll do both of these, but is it clear? I mean, is these first two lines okay? And then like you see, you got to divide by this, and get it over. Okay. Now, in terms of the antiderivatives of this, that's where you could overthink it. It ends up just being the natural log absolute value 1 plus y.
Okay.
Sometimes it's good to review those antiderivative rules and not overthink them. This is x plus 1/3 x cubed plus c. Okay, and this one you can solve for y. For lack of a better word, you would just e both sides. You're undoing the ln with e with its inverse functions. This is 1 plus y equals e to the x plus 1/3 x cubed plus c. But this e to the c right here could be written as c. So sometimes you will see the answer presented this way.
Okay.
And if you need more clarity on that, let me know. And then you can subtract 1 from both sides to get y by itself.
Okay. Okay. That would make sense.
Okay. And then you said 10. We'll look at 10.
9.
9. Sorry. 9. 10 is the next grouping. So I mentioned like you need to multiply and divide here. Generally, so if we divide by e to the x, you have y prime plus 1 equals 1 over e to the x, which is really e to the minus x, which is probably a better way to write it.
Yeah.
And I said, well, you generally don't add and subtract, but here you actually do. You end up subtracting 1 because you do need to kind of isolate that y prime, that dy dx. And then you clear the dx by putting it on the other side. So it's integral dy equals integral e to the minus x minus 1 dx.
Okay.
And then your antiderivatives are y equals, this is a u substitution, but maybe you're so comfortable now, which is my hope, that you can realize, oh, I just moved the u part, the du out in front of it, minus x plus c. And you're done.
Okay.
All right, so the grouping 10 through 14, they're different problems, obviously, but like 1 through 9 could all be initial value problems if I give you some initial value. And I mean, they don't necessarily need to be more complicated. Like 10 is more complicated for whatever reason. but that it doesn't have to be. We should do 10 to start. All right, so what I see is let me get rid of this first, x squared plus 1. I'll just divide it on both sides. So that's 2y, y prime plus 2y prime equals x over x squared plus 1. And then what I notice on the left, I say, oh, well, there's a y prime in both, and I can factor out y prime, which is a 2y plus 2. And that helps me to say, okay, well, basically then I basically have this thing kind of separated. I mean, these are all separable differential equations, which means there is a way, there is a path. It's not impossible. So this is dy dx, but by convention we usually put the dy after the thing, the whatever is here over here, this function, and then the dx will move over here, so it's integral x over x squared plus 1 dx. Okay. So antiderivatives, y squared plus 2y, not bad. This one over here, a little more involved. What do you see for this? Probably a good time to get you to.
Shoot.
Like if it was 1 over 1 plus x squared, that's arctangent or
Yeah.
tan inverse, but it's not. It's an x, and we just did one. If it's 1 over 1 plus x, it's natural log 1 plus x, and they're not the same, but they're kind of close enough that they could actually all be messy. This one has a u sub.
Yeah.
Do you see the substitution? Do you see something else that's the derivative that's in there? It's okay if you don't. I'm just asking. So x squared du is x squared plus 1. Du is 2x dx, and that's what I meant by like the derivative of the bottom is the top, even though it's not a perfect top. It's just got a number out in front. So it becomes the integral x over u. Dx is du over 2x. The x's cancel, and you end up getting 1/2 the integral 1 over u du, which is 1/2 natural log abs value of u plus c.
Okay.
Y squared plus 2y equals 1/2 natural log abs value of u plus c. And we're not done, but we've done a lot. We have to use the initial value. So y of 0 equals 0. And this is a good point in time to put that in.
Okay.
Maybe not. Nope. I'm sorry. This is wrong. I need to back substitute my u. What was it? X squared plus 1. What was this? What you were going to tell me, or something else
No,
that I missed?
when you turned 2y into the antiderivative to y squared, isn't the formula for antiderivative like the variable n plus 1 over n plus 1?
Yes. So let's look at that. So it's y to the 1. So we would add 1 and divide by 2, but this 2 comes down.
In my mind, I was bringing the 2 as the 1. So
Yes.
it's 2 plus 1. Okay.
It's okay to do this. I do a lot of numbers all day long, and I still, I check things. I mean,
I like to think about for a second. Okay. Mix them up. Okay. We can
okay, so we get down to this line, and this is where you really want to, like, you don't want to solve for y and then do this. You really want to try this. And one of the things I had noticed is that if this was u, when I put 0 in for natural log, I realized it was undefined. So I knew there was a mistake there. So it has to be defined. This may be a check, but this is 0 squared plus 2 times 0, lots of zeros, 1/2 natural log 0 squared plus 1 plus c. So you get 0 plus 0, which is 0. Natural log of 1 is 0. And this does mean that c equals 0. And the importance here is that you're writing, you're solving the initial value problem, meaning there are no constants of integration. There could be constants, but not constants of integration. which is
Okay.
what C is. C is a constant of integration.
Okay.
Okay, so why don't you look at 11 through 14 and see if one or two or all of them stand out to you as ones
Okay.
worthy of doing. Actually, 13 and 14 are kind of, well, 13 is already solved for dy. I mean, you just do that. But yeah, we can do whatever you would like here, but take a look at those, please, and see if there's something that stands out.
I don't know. I think we only need to do like one more, but I'm not sure which one. Is there one
All right,
that's
let's.
the hardest out of all of them?
No, students never like my answer. They're all equally difficult because I've done these so many times. For a student, though, 13's, I guess.
13?
13's worth doing because it's got to use substitution in it. Maybe that's one reason to do it. Okay. Yeah, so notice there's no y's over here on the right, and it's already says dy. So you're already set up here to do this.
Yeah.
And it's reasonable to actually ask, well, where's the dx? I don't know why they didn't write it. This should just say y prime to make it correct. There's a mistake in this, but nevertheless, this is a u substitution here on the right. Can you tell me what the u is for this?
The u would be 1 plus x cubed.
Yes, and as a reminder, it's denominators or parentheses or exponents or under roots. Yeah. But more importantly is when you take its derivative, it better show up in the rest of the problem. Yeah. Minus the constant, or well, with a little bit of nudging, it should be there. So dx is du over 3x squared, and you substitute in what you know, and if you don't know it, then don't substitute it in. And that's what you're hoping, is that it does cancel out. So those cancel out. And this is the integral of 1/3 integral 1 over u squared du. This is a power rule integral. If it's helpful, you can write it as u to the -2. But it's like you said, you add 1 to the exponent, you divide by the new exponent, and then you have to back substitute. So I would bring the negative here. So I would go -1/3 1 over u. Your u was 1 plus x cubed.
Yeah.
Plus c, and on the left it is y. Your initial value is y of 0 equals 1/2. And this is a good place to try to figure that out. So 1/2 equals -1/3 1 over 1 plus 0 cubed plus c. So you got this thing right in here, 0 cubed is 0, 1 over 1 is 1. So it's -1/3 plus c. So you're going to add 1/3 to both sides. That's 5/6 equals c. And you plug that back in there.
Okay. Gotcha.
You probably can do those. I don't know, I look at, sometimes I look at things like puzzles, like we were doing one earlier where it had like weird factoring thing. I guess this is the last comment I'll make. I look at this like puzzles. So I might like start a problem like this, and then if I can't figure it out, I'll come back to it because my brain will keep working on it. So if you can't figure it out, just give yourself a little break and go do something else and come back on the test. So next piece you sent over, let's see here, 42 problems here. 35 is kind of a fundamental theorem of calculus stuff.
Okay.
Oh no, it's weird.
Yeah.
There's no bounds. Do you have the answer to like 39 in the back of your book, or 41?
It's online. I can try and pull it up.
Yeah, at some point, I don't think that's being emphasized here, but we might as well at some
Yeah.
point talk about it. All right, I'm gonna start with 6. I'm sorry, 39 would be great.
39.
39.
Is x cubed square root of x minus 4.
Okay. Yeah, these are really odd because they didn't give you any limits of integration, which means the answer is just what the integral is of.
Huh.
Yeah, I don't know.
Okay. So I guess
We're not doing those. Those aren't helpful.
it's not
But
going to be on the test.
no, no. I'm gonna start with 6. Do you have all of them, like even the evens?
Do have all the answers.
Okay.
Because
Okay.
this is online, not in a
Yeah.
test. They give me all the answers.
Okay. Yeah, Chegg is really a good resource also.
Yeah, I used it a lot when I took physics last year.
Yeah,
Very helpful.
yeah.
I splurged and bought like the premium. I was like, I need this. I need
Yeah, and there's many more
yeah.
tools like that when you get to college.
I'm just
Because
laughing over physics. Made it
yeah.
out.
Okay, so this one, just as a reminder here, you do need to negate your exponents to be able to do this. And you can have other variables. It doesn't have to be x, but you're going to add 1 each time. So that's -6 over the new exponent, -3 over -3, and 1/2 z squared plus c. Do not forget your constant of integration. And then you just have to simplify if you need. Okay, so that not overly difficult. Problem like 8 though, kind of introduce. Let me actually, let me vary 8 slightly because it doesn't incorporate all the things I think you might see. So let me just rewrite it here. Integral square root of u cubed -1 over 2 square root of u plus 5 du. So this is what they're emphasizing here is like your ability to handle exponents that are fractions and rewriting. There's a rewrite step before you would integrate this. And if it's not clear, let me know. But do you see how the first one becomes u to the 3/2 power?
Yeah.
Okay, fantastic. The next one, it's really 1/2 times 1 over square root of u. So you could actually, and this is where we're talking about this. Like I would ultimately want you to be able to write 1/2 u to the -1/2 like this.
Yeah.
And we have not integrated yet, to be clear. Like we're still just rewriting.
Yeah.
Great. So adding fractions, u to the 5/2. It is over 5/2, but really want you as a calculus student to be able to flip that as you're doing it and write. I want you to be able to go to this line right here as you're doing it. If you can't, that's okay, but that's the goal.
Yeah.
You're adding 1 to this one, so it's u to the 1/2. So you are dividing by 1/2, but that means you're multiplying by 2. 2 times 1/2 is 1, so it becomes -1. And then what about this? What's the antiderivative of a constant?
The antiderivative?
Yes.
Would it just be 5u?
Yes. Yes. Plus c.
Okay. And then I don't need to simplify anymore for that one, correct?
No, no.
There's nothing else.
Nothing else. But if you, depending on how you do it, you may end up having to rewrite a few lines here.
Okay.
So out of like 1 through 10, and maybe looking more at like 5 through 10, is there anything there that looks uncomfortable to do on your own?
Oh, you changed the 3. Sorry, I was looking.
Yeah, I modified 8. 8 was modified by Matthew.
No, not by that, but like I was getting confused because when you it went to 2 over 5 u 3 over 3 halves. I was confused because above it was. Never mind. I got it. Okay.
Yeah. Okay, yeah, and there's a lot going on. It's like add one, divide, but then you do the reciprocal.
Okay. Which ones do you want me to look at again? Sorry.
5 through 10. Just is there anything there that you want us to do? Because they're all exponent power rules that are the same type but different difficulty based on the numbers.
5 through 10. I did one like that. Did one like that. Let's do 10.
Sounds good. Snipping that in now. Okay, so these are just power rules. So we're gonna add one to there actually is no rewrite needed this time. Possibly let's read just the first, this first one could have been written like that, and then rewritten into that form. You really want it to be a number, a variable to an exponent. So you're adding one, dividing by the new exponent, adding one. So if you need to write it out, it's 3/3. So it's v to the 8/3 divided by 8/3, but you can just put the reciprocal there. It also helps to kind of visualize this thing multiplying this thing and getting back to 1, which is why it is the flip of that, plus c.
Okay. That it?
Yep. Sorry, it's underwhelming.
For 3v to the 6 over 6, could you simplify that into 1/2?
Yes. Yeah, and you should. You should. That's yeah.
Just want to make sure. Sometimes there's weird rules and they don't even do it.
Yeah.
Okay.
Okay, so we're gonna look at 10, 11, and there's actually 2 ways to do 11. There's like when you first learn about antiderivatives and you didn't know anything else, the only way to do this problem was to FOIL this first.
Yeah.
And then do the antiderivatives, which is correct. There's actually nothing wrong with that. It is a U-sub problem though. Like, if I were to give a finished calculus student this problem, I would hope they would recognize this. But if you don't, that's okay. This is correct too. It's this, it's 2 ways to get to the same place. Your du is 3 dx, so it becomes integral u squared du over 3. Okay, and so our antiderivative is, well, let me rewrite it here. It's 1/3 integral u squared du, 1/3 times 1/3 u cubed plus 3 plus c, and then you back substitute your u. So it's 1/9 because you can multiply those together. 3x minus 1 to the power of 3 plus c.
Okay.
So this is correct. The other way is also correct. If you use a Chegg or you just throw it into some math thing that does it for you, that's where the instructors sometimes know, like what are you doing? Because this is a U-sub problem. Why are you, and you give them some weird answer.
Yeah.
Depending on whether they're looking or not.
I think for the answer, when they give the answers on this worksheet, I think they went with the not the U-sub one, the other one.
Right. So having said all that, I'm gonna grab question 12, and this one you have to FOIL.
Oh. Can't.
Yeah. So we had all this discussion about, oh, you don't want to do that, but this one, the only way to do this one is to multiply these out.
They're sneaky.
Yeah.
You could divide it, and then they're like, oh, but here's the one that you only can do it this way.
Right.
You sub and you can make an easy mistake. Trying to get you.
Yeah. So the FOIL here, it does reduce this a little bit. You get x squared when you do the outer, it's -1, the inner is -1, and the last is 1 over x squared. So you get x squared minus 2 plus, I'm gonna write it this way, x to the -2.
Gotcha.
And then you find your antiderivative of that. So you're integrating x squared minus 2 plus x to the -2 dx, 1/3 x cubed minus 2x minus x to the -1 plus c.
Gotcha. Okay.
Okay. 13. Maybe we'll just talk about.
Sure.
And same with 14, I guess. They're kind of the same category. In both of these problems, you have products.
Okay.
And because you have a product, you really need to multiply it.
Okay.
In this one, you need to FOIL. There's not a known method for integrating these. Although an integration by parts might work, although it'd be really complicated for this, but it might work. Can you give me 30 seconds to be right back?
Yeah, go ahead.
Okay. All right, I am back. So that kind of concludes the discussion of like, well, actually I take that back. There's more, there's quite a few more of these. The next grouping, 15, we're going to do 15, but it's like you do have to do the simplification, whether it's multiplying or dividing. But we should look at 15 next as a reminder here. So sometimes when you get so into calculus, you forget like, oh yeah, I can do just these operations. Like this bottom thing is x to the 1/3. And if you divide both of these by x to the 1/3, you get a nice power rule thing. So this is 8x to the 2/3 because you're subtracting the exponents. Here, you're just rewriting it as a negative exponent. And these antiderivatives, while not amazing because they're not numbers, they're not nice numbers, they are doable. So you get 5/3, 3/5 times 8. And then here you got x to the 2/3, 3/2. Yeah, I flip it and put the 5 there. And then you would write like 24/5 x to the 5/3 minus 15/2 x to the 2/3 plus c. I might as well mention this now. Like at the University of Arizona, their business calculus classes, they always rewrite these answers like this to confuse students.
Oh.
And I'm not saying you're going to get that because I don't know, but
Yeah.
There's other ways to write the answer exactly the same.
I actually did decide where I'm going to college. Little thing.
Where are you headed off to?
I'm going to New Orleans. I'm going to be going to Tulane.
All right, congratulations.
Thank you. I'm excited. It's going to be a culture shock.
Yeah.
It's fun.
have you been there before?
Yeah, I went over the summer to visit the school.
You went over the summer. Okay.
One, so.
Great. No, that's great. And do they have the degree program you wanna study?
Really, I'm gonna do art history, and I think I'm gonna eventually go into business.
Okay.
I want to do art history business, but right now I'm double majoring. I'm going in as a double major in art history and economics, and minoring in Spanish.
You're gonna be busy. You got a lot there.
Yeah, we'll see. I might drop something. Probably will. But yeah,
Great. That's great. That's, I could hear the excitement when you said that. It's a big deal. It's
only a few more weeks and we're done.
yeah. Are you gonna do any stuff there, or are you just gonna wait till the fall to get going?
I'm just gonna wait till the fall. There's a bunch of online stuff I
Okay.
need to do, like placement tests and things like
Yes.
that. But
Yes.
freshmen also get
Yeah.
there early and they have a whole like orientation type of thing. So
Mhm.
it'll be good. But
Great.
yeah.
Great.
Okay, back to math. Sorry.
Back to the really interesting stuff. No, this is not interesting. None of this is. I'm not going to defend any of this because it's not. 16 is like what we were doing.
Yeah.
Go ahead.
Fun when you know how to do it.
Yes.
Anyway, like
So 16 is like the previous problem. This one is a slightly different. You have to factor. So remember, factoring and foiling kind of go together. You have to factor the numerator, which is difference of cubes, which I would not expect you to know, but like you could be asked to do that.
Okay.
We're going to look at 18 because I think 18 is slightly more reasonable because it's similar to one we were doing with the separation of variables. So the numerator is a factor by grouping.
Okay.
So the numerator becomes x squared x plus 3. No, I'm wrong. I'm sorry, I'm wrong. This is something else. Let me look here. This one may require you to do polynomial division.
Okay.
But I don't want to comment on that. Let me see what else this thing has for us to look at. I guess the takeaway is that like they're just doing more things to confuse you. Not necessarily anything difficult, but like they're just disguising what it already is.
Yeah. I mean, they won't like, my teacher won't give us crazy ones from like old.
Yeah.
It'll probably be more like the earlier ones we did. But crossing my fingers.
Yeah. And now that I'm looking at this a bit more closely, you're not doing any U substitutions in this part of the course. I didn't really understand where you were. So none of these are U substitutions, even though we did them that way. It's like one of those things where once you know how to do it, you can apply it to old problems. But let's see here. So the rest of this is kind of moving into some trig stuff. So let's just, and I like to do it this way. Let's say y is sine of x. Okay, your y prime is cosine x. Your y double prime is minus sine x, and your y triple prime is minus cosine x, and then it repeats. But the reason this is important is you need to be able, as a calculus student, be able to quickly do this. What is the antiderivative of sine x? Well, it's going the other direction. Like the derivatives wrap around this way, the antiderivatives go, yeah, negative cosine x. And you also need to be able to find the integral of cosine x, which that one's the nicer one. That's sine x.
Okay.
So like 21 and 22 are of that type. Now let's look at 23 together. This is a disguised.
Yeah, I wouldn't be shocked if you gave me some trig.
Yeah. So like this is a reciprocal. What do they call them? If you look at your trig reference sheet, there's reciprocals, and cosecant x is 1 over sine x. And so if you flip the left, you flip the right.
Yeah.
And so this becomes 7 sine x dx. This is not calculus. This is like a rewrite step. But now it's okay. Well, I know the antiderivative of sine. It's minus 7 cosine x dx plus c.
Okay.
24 is really similar. You can look at that on your own. let's go to 27, I guess. So one of the strategies is to just rewrite everything in terms of sine and cosine. You probably heard that in trig at some point, or algebra 2 trig, pre-calculus. So secant is 1 over cosine, but 1 over cosine is also secant. So this you could, it depends on how you want to visualize this. You either visualize it like that, which is fine, or you visualize it as 1 over cosine over cosine. This one on the right gives you 1 over cosine squared t, which is secant squared t. And this, if you do the substitution here on the left, this is secant t. So you get the same thing. You get integral secant squared t, no matter how you do it. So I'm going to send you in the chat this this link to Lamar's common integrals and derivatives. I think for sure for this test you want to have this available. Like in general, you wouldn't be expected to know the more complicated antiderivatives, but you know, secant squared is on there.
Yeah. Okay.
And if you haven't looked at it in a while, you might be like, well, how do I do that? I mean, integration by parts, like, no, that's way too complicated. It is just, I mean, it's just secant. I'm sorry, it's just tangent of t plus c.
Yeah.
But if you haven't looked at that in a while, you may misremember.
Yeah.
How to do it.
I did remember that one, so.
Good. That's really good. After the first mini test quiz thing that you're taking, you might get a feel for the style of the questions. Like maybe they are just being pulled from.
So I might have better ones for next.
Yeah, to maybe try to focus on that is my suggestion, you know.
I'm kind of blindsided. I don't really know what's gonna be for sure, like what type of problems, but I'll get a feel for this one and look at these ones. Yeah.
Number 30, here's one we can look at, kind of emphasizing another thing. So when you look at this, the 4s should stand out. You'd be like, wow, they both have 4 in there. And that's because this can factor into 1 plus tangent squared v. And there are 3 trig identities. There's sine squared plus cosine squared equals 1. And then there's 1 plus tangent squared equals secant squared, and 1 plus cotangent squared equals cosecant squared. And I'm showing you this problem because it's the middle one. This becomes the integral of 4 secant squared v dv. But if you haven't looked at these in a while, you may or may not remember them. And then it's just like the last problem in terms of its
4 tan v.
4 tan v, yeah.
Okay.
So maybe look at 30, you know, I'm looking at that right column, starting at, you know, 29, 31, 32, 33, 34. Any of those stand out to you?
30. Maybe either 31 or 32. Just
that. This is one of those maybe convert everything to sine or cosine.
Okay.
But that's just one strategy.
Okay.
Like because I stare at this stuff for too long. Like I say, oh yeah, that's cosecant. Okay. So this is really cosecant w, cosecant w. So it's really cosecant squared w. And that's really useful because it's I believe that is one of the antiderivatives that you're supposed to know. Yes, it's the minus cotangent W plus C.
Okay.
But if you wrote like cosecant as cotangent, I'm sorry, that's not right. If you wrote cosecant as 1 over sine W, cosine W, and then sine W, I mean, maybe you would go the wrong direction here because you get sine squared W like that. Not sure.
Yeah.
But it is not a bad antiderivative once you kind of see it. And that's kind of thing I guess I would have you take away from that, is that none of these were meant to be complicated. They're just U subs. No, they're not. I'm sorry, they're not U subs. They're just like manipulated to get it.
Yeah. Yeah.
So in the last 2 minutes here, we can actually do 35 through 42. The answer is the part in the box here. So we'll just that'll indicate that that's the answer. It's just, that's your answer plus C. That's your answer plus C. And so on. I don't even know why this is here, but this is one of the fundamental theorems of calculus. If you want to look
You just
later.
know that because it's the D over.
The derivative of the integral is the same as the integral of the derivative in almost all cases. So
They're annoying with that.
yeah. Maybe you get 8 of those. You can just write out the answer.
That would be very nice.
All right. Well, I know we got a lesson, I guess, on Sunday. So I'll see you then. And thanks so much for scheduling.
Thank you. Have a good one.
You too. Bye.